Welcome to The Explainer. Today, we're diving deep into the science of serotonin. You've probably heard it called the happy chemical, and it plays this huge role in your mood, your sleep, and even your appetite.
So what do these three things possibly have in common? It kind of sounds like the start of a weird joke, right? But the answer is actually pretty fascinating. They all influence a single, really powerful molecule that shapes how you feel every single day, serotonin.
Now, to really get a handle on what serotonin does, it helps to put it next to its more famous cousin, dopamine. You probably know dopamine. It's that go-getter chemical. It's the thrill of the chase, the reward you feel when you achieve something. Well, if dopamine is the chase, serotonin is the feeling of contentment. It's not about seeking happiness. It's about feeling stable, calm, and, well, right where you are.
Okay, so let's get into it. We're going to trace the entire journey of a serotonin molecule. And believe it or not, it all starts in a place you might not expect at all, your plate. Yup, you heard that right. The road to a stable mood literally starts with what you eat. See, our bodies can't just magically create serotonin out of thin air. They need a specific raw material, a key ingredient that has to come from our food.
And here's the really crucial part. We can't make this stuff, tryptophan, ourselves. It is an essential amino acid, which is just a fancy way of saying we have to get it from our diet. So for real, the path to that so-called happy chemical in your brain begins at the dinner table.
All right, so let's move on to the next stage. Let's see how our bodies perform this kind of amazing bit of molecular alchemy, turning an ingredient from our food into one of the most important chemical messengers in our entire brain. Okay, I know this looks super complicated, like something from a chemistry textbook, but don't worry, we're going to break it down. This whole map is basically just a two-step recipe that our bodies use to turn tryptophan, that stuff at the top, into serotonin, the prize at the bottom.
So what's this recipe? Well, first, tryptophan gets grabbed by an enzyme called TPH. Now, this is the most important step because it's the slowest one. It's what scientists call the rate-limiting step. It basically sets the speed for how fast all serotonin can be made. Then, another enzyme, AADC, jumps in and does the final little tweak. And just like that, you've got serotonin, or as scientists often call it, 5-HT. So, our bodies made the serotonin. Great. Now what? I mean, what is its actual job in the brain? How does it go from being a molecule to influencing our actual thoughts and feelings? Well, think of it like this. Serotonin is a chemical text message. It gets sent from one brain cell, travels across this tiny, tiny gap called a synapse, and then it delivers its message to the next cell. And that message can be about anything, your mood, your appetite, whether you feel sleepy or awake. But you can't just have that message echoing forever, right? So the brain has this super efficient cleanup crew. It's a protein called SERT, the serotonin transporter. And its one and only job is to act like a tiny little vacuum cleaner, sucking that used serotonin back into the cell it came from, so it can be used again later. And this just shows the whole process perfectly. You see the serotonin getting released, it zips across, delivers its message, and then, whoosh, SERT swoops in and vacuums it back up, which stops the signal. When it's working right, it's this beautifully balanced and efficient system. So that leads to a really big question. If lower levels of serotonin in that gap are linked to things like depression, can we intervene in this process? Is there a way to, hack the system to make it work a little differently? And that brings us to one of the most famous types of medication on the planet, SSRIs. That stands for Selective Serotonin Reuptake Inhibitors. It's a mouthful, I know, but the name tells you exactly what it does. It's designed to do one thing, inhibit or block that reuptake, that recycling process we just saw. The way it works is actually pretty clever. Remember that little SERT vacuum cleaner? Well, an SSRI is like putting a tiny little cap over the nozzle. By blocking it, the serotonin doesn't get cleaned up as fast. It hangs out in the synapse for longer, which gives it more time and more chances to deliver its message to the next brain cell. Now, check this out, because here you can see exactly how it works on a molecular level. That big structure on the left, that's our SERT vacuum protein. And that smaller molecule wedged right inside of it, that's the SSRI. It's physically plugging the hole. This blockade is what stops the serotonin from being recycled, basically turning up the volume on its signal. And you've almost definitely heard of these medications. Prozac, Zoloft, Lexapro, they're household names. And they are all SSRIs that work on this exact same principle of blocking that little vacuum cleaner we've been talking about. But, and this is a really important but, messing with your brain chemistry is a delicate business. Because serotonin does so many different things in the body, not just mood. These drugs can come with a whole range of potential side effects, from an upset stomach all the way to changes in your sleep.
It's also so important to know the risks. The FDA actually requires what's called a boxed warning. That's their most serious level of warning on these medications. And that's because in some people under 25, these drugs can actually increase suicidal thoughts, especially right when they start taking them or when a dose is changed.
So, okay, let's step back from the world of medication for a minute. It's pretty clear that this one tiny molecule plays a massive role in our overall well-being. So the natural question is, are there other ways to support this system? And the good news is, yes, absolutely. There are tons of ways to naturally support your body's serotonin system. For instance, getting some aerobic exercise can help more of that tryptophan get into your brain. Getting some sunlight helps your body make vitamin D, which then helps turn on the enzymes that make serotonin. And, the simple stuff, prioritizing sleep, practicing mindfulness, or even just hanging out with friends. All of these things can make a real, measurable difference. So when you trace it all the way from a simple amino acid in your food to this complex signaling system in your brain, the story of serotonin is pretty incredible. It shows us this elegant, intricate system, but it also leaves us with a really big, thought-provoking question about our own role in managing it. In this delicate chemical balance, how much should we really intervene?